Hello everyone, welcome to Incredible Study. Today in this video we are going to understand the detail about coordinate covalent bond, and this is the fourth part of chemical bonding topic. So here in this video we are going to understand detail about coordinate covalent bond. So without getting delay, let's get started. As we have studied in the previous video of covalent bond topic, that the covalent bond is formed by the sharing of electron pairs. Similarly, coordinate covalent is a special case of covalent bond. In this, the sharing of electrons also takes place and the donating of electron pairs also takes place. So here, two atoms take part in the formation of coordinate covalent bond, and one atom is responsible for donating the electron pairs and another atom is responsible for accepting electron pairs. So the atoms that donates electron pair is known as donor, and the atoms that accepts the electron pair is known as acceptor. And there is one condition for donor atom. Donor atom must have completed its octet state, and acceptor atoms get electron pair from donor atom. So the coordinate covalent bond is the bond which is formed by donating the electron pair from donor to acceptor is called coordinate covalent bond, and the corresponding covalency is called coordinate covalency, and the corresponding compounds is called coordinate covalent compounds. So here I am going to write everything about it here. So here you can see this is the explanation of coordinate covalent bond. So here these all are written in point wise. First number, it is formed by sharing of valence electrons between the two atoms, but shared pair of electron is donated only by one of the two atoms. The other atom simply participates in sharing. As I have told earlier that among two atoms, one take part in donating electrons. Here you can see pair of electrons is donated only by one of two atoms, and the other atom just participates in sharing. Okay, so here second number, the atom that donates an electron pair for sharing is called donor atom. The atoms that donates the electron pair for sharing is called donor atom, and it must have already completed its octet state. This is condition for donor atom. It must have already completed its octet state. Octet state should be completed earlier. Third number, the atom which accepts an electron pair in order to complete its octet state is called acceptor atom. Here you can see the atom that accepts electron pair in order to complete its octet state is called acceptor atom. Here next number point, thus a chemical bond formed by donating a lone pair of electron from donor atom to acceptor atom is called coordinate covalent bond. So here you can see the bond which is formed by donating the electron pair from donor atom to acceptor atom is called coordinate covalent bond. So here about lone pair I have discussed in the previous lecture, so you can watch it. The link is in description. And the corresponding covalency is known as coordinate covalency. Here about covalency I have also discussed in the previous lecture, and the resulting compounds are known as coordinate covalent compounds. So here the corresponding covalency is known as coordinate covalency, and the resulting compounds which is formed by the coordinate covalent bond is known as coordinate covalent compounds. And here last point, it is represented by solid arrow. You can see here pointing towards acceptor atom from donor atom. So here consider A and B are two atoms. So here A is donor atom and B is acceptor atom. So the coordinate covalent bond between these exists in this form. So here the coordinate covalent bond here denoted by point arrow, solid arrow pointing towards acceptor atom from donor atom. Here you can see it is represented by solid arrow pointing towards acceptor atom from donor atom. So this is the full explanation about coordinate covalent bond. You can even copy these all. Now we take some examples to understand clearly about the formation of coordinate covalent bond. So now we take these all compounds and we saw the formation of coordinate covalent bond in these all compounds. So first number O3 molecules. So here O3, and here first we have to write electronic configuration of oxygen atoms. So here the electronic configuration of oxygen atom is 1s2, 2s2, 2p4. Here 6 and 2. Since there is 3 oxygen atoms, so here we write 3 oxygen atoms. 3 oxygen atoms. Now here just write its valence electron. These all are valence electron. If you feel any difficulty to understand these all, then you can watch previous lecture. Here these all are its valence electron. Now here you can see between 2 oxygen atoms covalent bond get formed. So here 2 pair of this electron is shared, and now you can see for this oxygen atom 1 2 3 4 5 6 7 8, and this oxygen atom 1 2 3 4 5 6 7 8. It means octet state is achieved for both oxygen atoms. So here any of 2 oxygen atom can donate 1 pair of electron to this oxygen atom. And remember, donating of electrons always takes place in pair. It means 1 pair, 2 pair, 3 pair. So here this 1 pair of electron is donated to this oxygen atom, and now this oxygen atom have 8 electrons in its valence shell. 1 2 3 4 5 6, and here these 2 electrons are donated. So here now you can count 1 2 3 4 5 6 7 8. So here we show the coordinate covalent bond like this. Here in O3 molecules, this is the formation of coordinate covalent bond, and here you can see this is coordinate covalent bond. Coordinate covalent bond. Here this is our first molecules in which we have shown this coordinate covalent bond, formation of coordinate covalent bond. Now we take another compounds, that is another example to understand that clearly. Next one we have SO2. So here we write electronic configuration of sulfur. Its atomic number is 16. So 1s2, 2s2, 2p6, 3s2, 3p4. Here 6, 8 and 2. 2, 8, 10, 6, 16. This is for sulfur. And for oxygen 1s2, 2s2, 2p4, 6 and 2. Here you can see only 1 sulfur atom and 2 oxygen atoms around it. And its valence electron, that is 6, 1 2 3 4 5 6, and here 2 oxygen atoms. So here 1 oxygen atom, 1 2 3 4 5 6, and another oxygen atom here, 1 2 3 4 5 6. So here 6 oxygen atom, 6 electrons around this oxygen atom. And here now you can see the covalent bond exists between this sulfur and oxygen atom. So here these 2 pair of electrons get shared, and here now for sulfur you can count here 1 2 3 4 5 6 7 8. And so here this octet stage is completed for this one single atom sulfur. So this sulfur just donate 1 pair of electron to this oxygen in order to complete its octet state. So here this for this oxygen 1 2 3 4 5 6 7 8. Here 1 2 3 4 5 6 valence electron, and here 2 more electron from donor atom, that is sulfur atom. So here the bond is denoted like this. Here sulfur, oxygen and oxygen. So covalent bond between this sulfur atom and oxygen atom, and one coordinate covalent bond between this sulfur atom and this oxygen atom. And now we take third example, that is N2O. Here N2O. Atomic number of nitrogen is 7. So here 1s2, 2s2, 2p3. Here this 3 to 5 and here 2. 5 valence electron for nitrogen. Here and for oxygen we know 1s2, 2s2, 2p4. This 6 and this 2. So here 2 nitrogen atom. So here we can see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Here 5 and 5 valence electron for 1 nitrogen atom and 1 here oxygen atom. 1, 2, 3, 4, 5, 6. Now you can see here covalent bond exists between these 2 nitrogen atoms. So here this pair 3 pairs of electron get shared between these 2 nitrogen atoms, and here octet state is completed of both atoms of nitrogen. Now you can just donate from any atom, nitrogen atom. Here I am donating from this. So 1 pair of electron is donated to this oxygen atom. Now we can write here bond coordinate covalent. Here this is coordinate covalent bond. This is triple covalent bond exists between the 2 atoms of nitrogen, and coordinate covalent bond exists between this oxygen atom and 1 nitrogen atom. And now we take another example, that is CO, carbon monoxide. So 1 carbon atom and 1 oxygen atom. Here for carbon atom we know its atomic number is 6, so its electronic configuration is 1s2, 2s2, 2p2. So here this 4 and 2. And for oxygen here we can see 6 valence electron here, and here we write carbon atoms, that is 4 valence electron, 1, 2, 3, 4. And here for oxygen atom 1, 2, 3, 4, 5, 6. So here now you can see this covalent bond exists between this. It means these 2 pair of electron get shared. Now you can see for oxygen 1, 2, 3, 4, 5, 6, 7, 8. Octet state completed, but in carbon atom 1, 2, 3, 4, 5, 6. It means it needs 2 more electrons to complete its octet state. So here oxygen just donate 2 electrons to this carbon atom. So now we can write here covalent bond and 1 coordinate covalent bond between this oxygen carbon atom and oxygen atom. Now we show the formation of coordinate covalent bond in N2O4. So here N2O4, and for nitrogen we have 1s2, 2s2, 2p3, 5 valence electron and 2 inner electron. So here, and for oxygen 1s2, 2s2, 2p4, 6 and 2. So here 2 nitrogen atom and 4 oxygen atoms. And here for molecule N2O4, here 2 nitrogen atom. So here 2 nitrogen atom we write and bond between these 2 atoms. And here oxygen atom, we just show electron first here, 5 valence electron for nitrogen. So 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, and 6, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, and here one more oxygen atom here and another oxygen atom, because there is 4 oxygen atom. Now 1, 2, 3, 4, 5, 6. The valence electron of oxygen atom is 6. So here covalent bond exists between this nitrogen atom and this oxygen atom, and even between these 2 nitrogen atoms, and even between these 2 oxygen atoms and nitrogen atom. So here 1 pair of electron gets shared, here 2 pair of electrons get shared, similarly 2 pairs of electron get shared. Now you can see for this nitrogen atom 1, 2, 3, 4, 5, 6 and 7, 8 octet state is achieved here. So this electron is donated to this oxygen atom in order to complete its octet state. Similarly, this one pair of electron is donated to this oxygen atom. Now here we write double covalent bond and single covalent bond between this nitrogen, because only one pair of electron is shared, and here between this, so and coordinate covalent bond between this nitrogen and this oxygen. So this is the formation of coordinate covalent bond in N2O4 compound. Now we take another compound as an example, P2O5. So here P2O5. For phosphorus we write here atomic number of phosphorus is 15. So here its electronic configuration is 1s2, 2s2, 2p6, 3s2, 3p3. So here 5, 8 and 2. 8 to 10, 5, 15. And oxygen, we know this is the electronic configuration of oxygen, that is 6 valence electron. Now 2 phosphorus atoms and 5 oxygen atoms. So we have to arrange these all atoms in such a way so that we can form coordinate covalent bond and other covalent bonds. So here we see phosphorus, and here for phosphorus 5 electrons. So 1, 2, 3, 4, 5, and similarly here we write in middle oxygen atoms 1, 2, 3, 4, 5, 6. Similarly phosphorus atom 1, 2, 3, 4, 5, and similarly one oxygen atom here, another oxygen atom here 1, 2, 3, 4, 5, 6. This electron we write this side. Just you have to, when you practice a lot, then you automatically knows the position of these atoms. And here this like this 1, 2, 3, 4, 5, 6. Now you can see one pair of electron gets shared here. Similarly one pair of electron gets shared. Now you can see for oxygen 1, 2, 3, 4, 5, 6, 7, 8. 8 electron is completed in its valence shell. Now for this phosphorus atom, here 2 pair of electrons get shared. Similarly 2 pairs of electrons get shared. Now 1, 2, 3, only 3 oxygen atoms we have, but we have 5 oxygen atoms in our compound. So here just 1, 2, 3, 4, 5, 6, 7, 8. 8 electron is completed. It means octet state is completed. So for here we write oxygen 1, 2, 3, 4, 5, 6. Similarly this side also 1, 2, 3, 4, 5, 6. Now this 1, 2, 3, 4, 5, 6, 7, 8. A octet state is achieved. So this can donate one pair of electron to this oxygen atom. Similarly this phosphorus atom can even donate one pair of electrons to this oxygen atom. So now here we show bond. Here double covalent bond between this phosphorus atom and oxygen atom, and single covalent bond between this phosphorus atom and oxygen atom. Similarly like this, and one coordinate covalent bond here and another coordinate covalent bond from donor atom phosphorus to acceptor atom oxygen. Now we take another H2SO4 as an example. H2SO4. Here 2 hydrogen atom, 1 sulfur atom and 4 oxygen atom. So here for hydrogen we know 1s2, and for sulfur 1s2, 2s2, 2p6, 3s2, 3p4, 3p4. Here 6, 8 and 2. 2, 8, 10 plus 6, 16. Atomic number of sulfur is 16. And oxygen we know 6. Its valence electron is 6. So here now we just arrange hydrogen, sulfur and oxygen in such a way so that coordinate covalent bond get formed. So here one sulfur atom, 4 oxygen atoms. So here 1, 2 hydrogen atoms and 1, 2, 3, 4 oxygen atoms. So here oxygen atoms, oxygen atoms. One bond completed, one bond completed here. And for sulfur you can see 1, 2, as sulfur has 6, you can see as sulfur has 6 valence electron, 1, 2, 3, 4, 5, 6, 7, 8 octet state completed for this sulfur. So this can donate one pair of electron to one more oxygen atom, and similarly this electrons is also donated to this oxygen atom. So now you can see directly, now you can write the formation of coordinate covalent bond. This is hydrogen. This is the formation of coordinate covalent bond in H2SO4. One sulfur atom, 1, 2, 3, 4, 4 oxygen atoms and 1, 2 hydrogen atoms. So H2SO4. Now we take another example, that is HNO3, and here we show the formation of bond in HNO3. Now HNO3. So here one hydrogen atom, one nitrogen atom and 3 oxygen atom. As this forms like this, oxygen is combined to this and here, and this nitrogen just donate one pair of electron to this oxygen atom. Now you can see this is the formation of bond in HNO3, HNO3. And now we show in SO4, that is SO4 minus minus. This is charge, it means 2 electrons is gained. Now for sulfur we know, here for sulfur we have written 6 valence electron, and just we directly write here 1 sulfur atom, 4 oxygen atom. So 1, 2, 3, 4, and on 2 oxygen atoms there is minus charge. So here 1 electron is achieved here on 2 oxygen atoms. So just it forms bond and this is donated. So now you can see 6, as we know 6 valence electrons are present in the valence shell of sulfur. So 1, 2, 3, 4, 5, 6 already present, and 1, 7, 1, 8 octet state completed. So it can donate one pair to this oxygen atom and one pair to this oxygen atom and becomes donor atom, and these two becomes acceptor atoms. Now we show formation of bond in PO4 minus minus. So here in PO4 minus minus minus, so 3 minus. Similarly we write for phosphorus 1s2, 2s2, 1s2, 2s2, 2p6, 3s2, 3p3, 5, 8, 2, 8, 2, 10 plus 5, 15. Atomic number of phosphorus is 15. So this is the electronic configuration of phosphorus. And for oxygen we know 6 valence electron, and here 3 minus, it means it denotes 3 oxygen atoms have minus charge, as similarly as same like this. So 1 phosphorus, 1, 2, 3, 4 oxygen atoms, and on the top of 3 oxygen atoms minus charge is present. It means it just forms single bond because 1 electron is already present in it. And here just we know 5, so 1, 2, 3, 4, 5. So this is donated to this. At first we see its octet state. 1 2 3 4 5 6 7 8 octet state achieved. Now it can donate one pair of electron to this oxygen atom. So this is the formation of bond, that is coordinate covalent bond in this PO4. Now we take another example, that will be our last example, that is NH4Cl. So this is salt and we know this is ionic. So here NH4Cl, it means formation takes place like this, NH4 plus Cl minus. Now we show the bond formation for this NH4 plus. So one nitrogen atom and its valence electron we know 5. So 1 2 3 4, and on the top of one hydrogen atom there is one plus charge. So it forms 3 bond and just it donate one pair of electron to this hydrogen atom, because here hydrogen atom has no any electron present in it. So here, and now plus this Cl minus charge. So this is the formation of bond in NH4Cl. So here we have taken these all as an example to understand the formation of coordinate covalent bond very clearly, and now we have concept about coordinate covalent bond. And at last, now we discuss the properties of coordinate covalent bond. Now we discuss the general properties of coordinate covalent compounds. So here first number, physical state. What is the physical state of coordinate covalent compounds? How they exist? So coordinate covalent compounds generally exist in liquid and gaseous state. They exist in here liquid state and gaseous state. Second number, solubility. What is the solubility of coordinate covalent compounds in water and other organic solvent? So they are partially soluble in water and other organic solvents. They do not dissolve fully. Third number, conductivity. So here they are poor conductor of electricity. They do not conduct electricity. Simply they are poor conductor of electricity. Fourth number, melting and boiling point. The melting and boiling point of the coordinate covalent compounds are lower than that of the electrovalent compounds and higher than that of the covalent compounds. Here lower than the electrovalent compounds and higher than that of covalent compounds. Fifth number, coordinate covalent bond is rigid and directional in nature. Here coordinate covalent bond is directional in nature and rigid. The sixth number here, last number, coordinate covalent compounds are molecular. Here since they are molecular, so the molecular reaction takes place in them. The reaction named molecular reaction takes place in them which are very slow, So here coordinate covalent compounds are molecular and hence undergoes molecular reaction which are slow. So here these are the general properties of coordinate covalent compounds that we have discussed. So in this video we have discussed detail about coordinate covalent bond, and in the next lecture we will be discussing about hydrogen bond. So for this video only this much, and I will catch up in the next one.